Section 6.3, Molarity. Just like with pure substances, relative amounts in a mixture are important in determining properties. Here, we are interested in finding the concentrations of substances in mixtures, which are typically expressed as molarity, where the unit is molar. Now, briefly, I want to review some terms with regards to solutions. Now, solutions are homogeneous mixtures, which means they are mixtures that look the same to our eyes. Now, substances in solutions that are present in the greatest number of moles is referred to as the solvent. The substances present in the smaller number of moles is referred to as the solute. So, for example, if you took some salt and put it inside water, the solute would be the salt, the sodium chloride, the solvent would be the water, and then overall the salt plus the water forms your solution or your mixture. Now, to calculate molarity, you're going to want to remember this equation. Molarity equals moles solute divided by liters solution, or generally we say that it's represented by the capital M. So capital M equals moles over liters. Now you can use this equation to rearrange and solve for other variables, like this, where liters equals moles over molarity, or moles equals molar times liters. But it's important to know that anytime you are using this equation, the volume must be in liters. It has to be in liters. So it's molarity equals moles over liters. Let's look at a brief example. This problem states a 355 milliliter soft drink sample contains 0.133 moles of sucrose. What is the molar concentration of sucrose in the beverage? Now here, again, it's important to remember that volume must be in liters. Okay, so let's think about how we do this. First, we should take that volume and we should convert it to liters. So 355 milliliters multiplied by this conversion factor, that is 0.355 liters. Now we can use our molarity equation. We've got moles, we've got the volume or the liters of solution. So we just take moles, 0.133, divided by the volume in liters, divided by 0.355, and we get 0.375 molar. So this beverage has a molar concentration of sucrose of 0.375. Let's look at another example. How much sugar in moles is contained in a modest sip, 10 milliliters, of the soft drink from the previous example, which was found to have a concentration of 0.375 molar. So here we are trying to find moles. So first, again, you should take that volume, 10 milliliters, and convert it to liters. So that would be 0.010 liters. Now we're solving for moles here. So to solve for moles, moles is equal to the concentration in molarity multiplied by the volume in liters. So this would be 0.375 molar multiplied by that volume, multiplied by 0.010 liters. And so we get 0.00375 moles. So there are 0.00375 moles of sugar in a 10 milliliter sip of that soft drink. All right, one more example. This problem states what volume in milliliters of a 0.05 molar sweetened tea contains the same amount of sugar as 10 milliliters of the soft drink in the previous example. So here we are being asked to solve for volume. So our 10 milliliter sip, it had 0.00375 moles of sugar. So here we're going to use this version of the equation where the volume in liters is equal to moles divided by molarity. So our moles is 0.00375. That's the same amount of sugar as that sip of the soft drink from the previous example, divided by the concentration of the tea, divided by 0.05 molar. And we get 0.075 liters. So if I had asked for the volume in liters, this would be the final answer. But you should notice here, again, I asked for the volume in milliliters. So take that volume in liters and multiply it by this conversion factor, and you get 75 milliliters. So the final answer here is 75 milliliters. Okay, now these previous problems all had the information given to you in moles, but oftentimes you'll be given molarity problems with mass. So remember, whenever you're using molarity, that concentration or that amount has got to be in moles. So you need to use the molar mass to convert between grams and moles. If you're given grams, you need to change to moles by dividing by the molar mass. Now, if you're asked to solve for grams in the answer, first you're going to want to find moles, then change from moles to grams by multiplying by that molar mass. Let's look at an example. A 0.0500 liter vinegar solution contains 25.2 grams of acetic acid, which has the chemical formula HC2H3O2. What is the concentration of the acetic acid solution in units of molarity? Well, step one, we're going to have to find the molar mass of acetic acid. You'll notice here that we are given a volume and we're given a mass and we're being asked to find molarity. And remember that molarity equals moles over liters. We've already got the volume in liters, so we need to find moles. And to find moles, we need to convert from grams acetic acid. So we need to find the molar mass of acetic acid. So HC2H3O2, so we've got 4 hydrogen atoms, 4 times 1.008, plus 2 carbon atoms, 2 times 12.011, plus 2 oxygen atoms, 2 times 15.999. And we get a molar mass of 60.052 grams per mole. Step 2, we're going to use that molar mass and the mass given to find moles acetic acid. So 25.2 grams times 1 mole over 60.052 grams. This gives 0.4196 moles acetic acid. Final step to the problem, use that mole value plus the volume in liters given to you in the equation or in the question to find the concentration. So 0.4196 moles divided by 0.500 liters gives 0.839 molar. So this solution has a concentration of 0.839 molar. Let's take a look at a solving for grams example. This problem states how many grams of NaCl are needed to make 0.250 liters of a 5.30 molar solution. So in this problem, you should recognize that you are given a volume in liters and you are given a concentration in molarity. And so it should click in your head, okay, I've got a volume in liters, I've got a concentration in molarity. That makes me think of the molarity equation. So I want to use the rearranged version of that molarity equation. So remember that molarity equals moles over liters. So moles is equal to molarity times liters. So we're going to plug those numbers in. 5.30 molar times 0.250 liters. And this gives 1.325 moles of sodium chloride needed to make this solution. Now the problem asked for grams. So if I want to go from moles to grams, I first need to find the molar mass of NaCl. So that's 1 atom of sodium, which is 22.990, and 1 atom of chlorine, 35.453. This gives a molar mass of 58.443 grams per mole. So last step, use that mole we calculated for in step 1, and use the molar mass we calculated for in step 2 to find grams. So 1.325 moles multiplied by 58.443 grams over 1 mole. And this gives 77.4 grams NaCl. Alright, now let's look at dilutions. Oftentimes in chemistry, so in chemistry labs, other than making solutions by dissolving solid into liquid, we will make them by diluting an already made liquid solution. And this is because it is usually easier to store and ship volumes of highly concentrated solutions and then dilute them later rather than send a big batch of the solid. So let's look at some calculations with dilutions. Now these calculations, they rely on the fact that adding solvent does not change the number of moles of solute, it just dilutes it. So moles of solute before the dilution is equal to moles of solute at the dilution, or N1 equals N2. Now moles equals M times L can be written as N equals M times L. So N1 would be equal to M1 times L1, and N2 would be equal to M2 times L2. Therefore, since N1 equals N2, we can say M1 L1 equals M2 L2, or more generally, C1 V1 equals C2 V2. So this is the equation we will use. C1 V1 equals C2 V2, where C equals concentration and V equals volume. It can be any units of concentration. It can be any units of volume. All that matters is that the units need to be the same on both sides. If your concentration, you can use mass. You could use grams here as long as it's grams on both sides. You could use moles as long as it's moles on both sides. Or with the volume, you could use liters or milliliters as long as the volume unit is the same on both sides. Let's look at an example. If 0.850 liters of a 5 molar solution of copper nitrate is diluted to a volume of 1.80 liters by the addition of water, what is the molarity of the diluted solution? So if you're doing a problem like this, right, you should recognize, well, I've got an initial volume and an initial concentration. Now I've got a second volume and I'm being asked to find a concentration. So that should make you think of C1V1 equals C2V2. So you just need to identify your variables here. The initial concentration is 5 molar. The initial volume is 0.850 liters. And the new volume is 1.80 liters. So I'm going to take this equation and I'm going to rearrange to solve for C2. So C2 equals C1 times V1 divided by V2. Now I can just plug my numbers in. Plug in 5 molar for C1, plug in 0.850 liters for V1, and plug in 1.80 liters for V2. And so we get 2.36 molar. 2.36 molar is our final answer. Let's have you try a knowledge check question. What volume of 1.59 molar KOH is required to prepare 5 liters of 0.100 molar KOH? Okay, the correct answer is A, 314 milliliters. So here I would call V1 5 liters and C1 0.100 molar, and then C2 would be 1.59 molar. So I need to solve for V2. When you solved for V2, you probably got, or you should have gotten, 0.314 liters, and then you convert that to milliliters to get the correct answer here. So A is the correct answer. Let's look at an additive volume example. This problem states a 45 milliliters of water are added to 250 milliliters of a 0.75 molar potassium sulfate solution, K2SO4. What will the molarity of the diluted solution be? Okay, well, our initial concentration is 0.75 molar, and our initial volume is 250 milliliters. Now you need to be careful here. This is an additive volume example, so V2 is not 45 milliliters. Rather, V2 is 295 milliliters. It's the 45 milliliters of water plus the initial volume of the solution. From here, now you can just rearrange and solve for C2. So plug in 0.75 molar for C1, 250 milliliters for V1, and 295 milliliters for V2, and you get 0.64 molar is the correct answer here. So just pay attention if you get an additive volume example. On the homework, and it's possible in the exam as well, you could get an evaporation type example where some initial solution evaporates and its volume decreases. So just pay attention to the context of the problem here. All right, last thing we're going to talk about in this section are serial dilutions. Sometimes we need to make a very dilute solution, or we want to make several different concentrations, each one more dilute than the previous. To do this, we can make serial dilutions. So let's say, for example, we had some sort of solution that was extremely concentrated, very highly concentrated, and we wanted it to get down to a 1 to 100,000 dilution. Now, maybe we don't have the necessary equipment to do this straight up, right? We don't have the equipment where we can just take, a teeny tiny amount of this solution and then dilute it with water. Maybe we just have some pretty basic glassware that's just marked every milliliter. So what we can do is make serial dilutions, where you take 1 milliliter of that initial solution and you dilute it 1 to 10. So you add 9 milliliters. Then you take 1 milliliter of this solution and you dilute it 1 to 10. Then 1 milliliter of this solution, dilute it 1 to 10. And you get the idea, and you can keep going. So this is a really easy way to very quickly dilute your solution without having to use any sort of complicated glassware or any sort of complicated calculations. Now, how do we do the calculations with serial dilutions? Well, what you want to do is you want to start out with your initial stock solution as C1 and solve for C2. Now, that new solution you just made becomes the new stock. So the C2 from the first calculation is now C1 in our next calculation, and we just continue from there, each time using C2 from the previous as C1 in the next. So for example, suppose I gave you a problem where it says, starting with a 2 molar stock solution of HCl, 4 standard solutions are prepared by sequentially diluting 10 milliliters of each solution to 250 milliliters. Determine the concentrations of all 4 standard solutions. So we've got a 2 molar stock. We're going to take 10 milliliters of that stock, then dilute to 250. Then take 10 milliliters of that solution, dilute to 250, 10, dilute to 250, 10, dilute to 250. Okay, so what we need to do here is start with our first calculation. So in our first calculation, the stock solution is 2 molar. We're adding 10 milliliters and we're diluting it to 250. So my first dilution, it has a concentration of 8.00 times 10 to the negative second. Now you should notice in our subsequent calculations, V1 and V2 is always the same. 10 milliliters, 250, 10, 250, 10, and 250. The only thing that's changing is C1. So the C2 from the previous calculation becomes C1 in the next calculation. And so you can see that all the way down the line here. So the math is the same in each step. You're just taking C2 from the previous calculation and making it C1 in your next calculation. And so you find the concentration for each of the 4 solutions. So after these 4 serial dilutions, our solution would have a concentration of 5.12 times 10 to the negative 6th molar. Okay, here are 4 practice problems for you to try. So as before, take a few minutes, pause this video, and give these practice problems a try. So try number 1, try maybe a couple from number 2, and try 3 and 4. And once you have given these an attempt, the answers are here on this slide. And again, you can download the slides to go through this at your own pace if you wish. That concludes section 6.3. I'll see you in the next video for section 6.4, other units for solution concentrations.